So down below we have empirical and molecular formula. Don't worry, we're not calculating anything. Yay. No? Woo! Oh, you guys look so disappointed. I'm just kidding. All right, so empirical formula. Okay, so we usually write it shorthand EF, all right? So empirical formula, has subscripts. What are the subscripts? The big numbers or the little numbers? Little numbers, all right. Has subscripts reduced to the lowest ratio. So what that is going to look like is with our ionic compounds, when we were learning about naming and formula writing, your ionic ones were always the ones where if you ended with like a 2,4, you reduce it to a 1,2, or a 2,2 reduced to a 1,1, right? So just like that, when we're dealing with empirical formula, that one is the one that will be reduced to the lowest one. Whereas molecular formula, okay, molecular formula can be reduced. Okay, so it's not at the lowest ratio. Okay, we call molecular formulas the true formula. I'm not going to ask you that tomorrow, but what I am going to ask you is, hey, create the empirical formula from this compound. What that's going to look like is I'm going to hand you something like glucose. All right, glucose right here, Z6H12O6. All right, first of all, we notice we have a 6, a 12, and a 6 ratio. Is that at its lowest ratio? Or can that be reduced? It can be reduced. What can all three of those numbers be divided by? A 2, but even more so, a 3, and even more so, a 6. We can divide all three of those by 6. Don't worry, I missed it earlier. All right, so we can reduce all of these by 6. So the fact that they can be reduced tells you that this is a molecular formula. So molecular formulas are the ones that can be reduced. So this says state the empirical formula for each of the following. So we're going to go ahead and change that to be the empirical formula of dividing all three of those by 6. So what is 6 divided by 6? 1. So we're going to have C. What's 12 divided by 6? 2. So we're going to have H2. And what's 6 divided by 6? 1 again. So we're going to have CH2O. This is your empirical formula for glucose. All that we're doing is we're reducing our little numbers. Just reducing them to the simplest ratio. Okay? All right, next we have N2O4. So we have a 2 to 4 ratio. Is that at its simplest ratio? No. Okay? So again, this is molecular formula. So we're going to reduce it to what empirical formula? We're going to divide both of them by what number? A 2. So what is 2 divided by 2? 1. So we're going to have N. What is 4 divided by 2? A 2. So NO2. All we did was reduce them. So think fractions. Back in the day when you guys had to reduce 2 over 4 is the same as 1 over 2. Things like that. Maybe? I don't know. All right. Letter C. We have Fe2O3. So now we have a 2 to 3 ratio. Is that one reduced as far as it can go? Yes. This is an empirical formula, so we can't reduce it any further. Okay. Look up at letter D. What is the empirical formula for D? CH. We reduced it down. What about letter E? Can't be reduced, so that one is already an empirical formula. Letter F. We're dividing all of them by 2, so what is the empirical formula? That's the ratio, so K, C, little too. Good.